Hi, this is Mr. Blay. This is a continuation. This is essentially part 2 of evaluating composite trig functions. Please make sure you watch part 1 before you get to this point. Okay, so continuing to evaluate composite trig functions, you can see here that cosine of inverse tangent of -3/4. So you'll notice that the cosine and inverse tangent, these are not inverses of each other. Okay, so if you have composites that aren't inverses of each other, these are not going to cancel out, which means now you have to tackle this in essentially 2 steps. So the first step is to tackle the brackets. Okay, everything in the brackets, we got to figure out what in the world this is. Okay, so inverse tan means we are looking for an angle. In other words, we're trying to figure out an angle of a triangle. That's essentially what inverse tan means. We also know that the 3 is going to be the opposite side of our triangle. We know the 4 is going to be the adjacent side. But we have to figure out those where the negative goes. Okay, does it go opposite? Does it go adjacent? Where's it going to be? Where again, this references back to understanding your inverses and understanding that inverse tangent is only in quadrant 1 and quadrant 4. These limited domains are crucial to understand. Since it's negative, it can't be quadrant 1. So when I draw this triangle, I need to draw it down here in quadrant 4, okay? So in quadrant 4, you can see it's the opposite side that's going to be negative, and it's the adjacent side that's going to be positive. Okay? The hypotenuse, which you are going to need to know, is 5. Most of you might know that it's a 3, 4, 5 triangle. If not, use the Pythagorean theorem to find that hypotenuse. So this is essentially that angle that we'd be finding, right? Angle unknown, okay? So you could go through the process of trying to calculate that angle, but if you don't have a calculator, that's not really gonna happen. Okay, so what you have to actually do though, since now we know the angle, in other words, we have kind of taken care of this box. We know what the triangle looks like, we know where the angle is. Ultimately, what the question is asking us, we found the angle as theta. This is essentially asking us what is the cosine of this unknown theta, right? This whole inverse tangent thing is really this theta angle. So your answer to the problem is really, what's the cosine of that angle? Well, I already have a triangle. I know what cosine is, because cosine is just my adjacent over my hypotenuse. So in order to get my answer, the cosine of theta is the adjacent over the hypotenuse. It's 4/5, and that's it. Okay, the angle itself doesn't actually have to be known. As long as you can figure out where the angle is in reference to the 3 sides, you don't actually ever have to find that angle. That's kind of the neat thing about understanding the triangle and being able to use the originals with the inverses. All right, so here's another example of it. I've got inverse cosine of sine of pi over 3. So you can see these are a little bit backwards. Now again, we're going to start with the brackets here. We're going to try and figure out what in the world is this sine of pi over 3. Okay, so sine of pi over 3, I know where pi over 3 is located. That's quadrant 1. So I'm going to draw myself a triangle here in quadrant 1. And more importantly, I'm going to label this as pi over 3. Which means I also know this angle up here is pi over 6. Now again, that's a 30, 60, 90 triangle. Which means in quadrant 1, I also know what all the sides are. Okay, this side is 1, this side is the square root of 3, this side is 2. Because again, it's a 30, 60, 90. Keep in mind the 30 is here, so the short side is opposite of it. 60 is here, so the longer side is opposite of it. All right, now again, you've got the triangle, you've got all the angles. Okay, so this box, you've essentially taken care of it. It's all drawn right here. So you just need to figure out, okay, for this angle, you essentially need to figure out the sine of this angle. So the sine is the opposite over the hypotenuse. All right, so this right here, this is your box, okay? The sine of pi over 3 is the square root of 3 over 2, okay? So to answer the final question, you figure out what the inverse cosine of pi over 3 over 2 is, okay? So again, inverse cosine. In other words, you need to figure out if this is my adjacent side and this was my hypotenuse, what angle would make those two things? So notice, if this was an adjacent side and this was a hypotenuse, this would be my theta, right? So my angle is actually pi over 6. That is actually your answer, okay? So remember, key things to sort of always remember over here in this example, it was an original trig function. So notice my answer is a ratio, okay? Because trig functions always give you ratios. See this as an inverse or started as an inverse? Notice I don't have a ratio. I essentially have an angle, okay? Because inverses solve for angles. Trig ratios solve for literally ratios of two sides, okay? So the other thing you can kind of do with this is the last piece of the puzzle, is you can also do these types of problems when you have complete unknown values, all right? So here's how this is done when you have literally x. It says, write the following as an algebraic expression of x that does not involve trig functions. Believe it or not, you're still going to draw a triangle, okay? And you're going to start here in the brackets, all right? So what sine is, this is inverse sine. We know this is x over 1, okay? So that means x is actually going to be my opposite side. It also means 1 is going to be my hypotenuse, okay? So we're going to draw our triangle, okay? Right angle. We're going to make this theta, and we're going to do opposite as x. We're going to do hypotenuse as 1, okay? Now, in order to do this, because in a minute we're going to have to take a tangent of this triangle, or tangent of theta, okay? If you do the tangent of theta here, okay, because theta is this angle, okay, you're going to need this side. You need opposite over adjacent. Okay, you can find this side using the Pythagorean theorem. Take your x value squared plus your unknown value, we're going to call this b over here for a second, equals your hypotenuse squared. All right, and if you solve this for b, remember we're solving for b, not for x. Okay, we're solving for the unknown side. All right, you're going to have b squared equals 1 minus x squared. And then when you square root both sides, this is the other length of your triangle, okay? So instead of b, this side here is the square root of 1 minus x squared, okay? I'm going to zoom this in a little bit so you guys can see that a little better, okay? So right there is what you have. Now the last thing, though, let me move this out of the way, is that we are trying to find tan theta over here. All right, so again, tan theta is opposite over adjacent. So my opposite side is x. My adjacent side is the square root of 1 minus x squared, okay? That really is ultimately your answer. It's the opposite over the adjacent side of that angle. The only thing you've got to do is you just got to rationalize the numerator and the denominator, okay? Because you don't want to have square roots in the bottom. All right, so therefore, once you rationalize those two on the bottom, the square roots cancel out, okay? So the bottom of your answer is 1 minus x squared. And the top is just x square roots of 1 minus x squared, okay? And that is your answer. I know it looks a little confusing, okay? But because you don't actually know what x is, okay, this would be your answer in this particular case, all right? For the next particular problem, you really do the same thing, okay? And again, because you're at the same situation here with the inverse sine, okay, you actually have the exact same triangle, all right? And the only thing that's different in this triangle is now where this theta is, you're just trying to do the cotangent of this theta. So in this case, it's actually just the opposite of this answer over here. Okay, so it really is just the adjacent side, which is the square root of 1 minus x squared, okay, over x. And that would be your answer for that one.